Does darkness merely represent the absence of light? Or could it be a tangible entity composed of its own distinct particles? A fascinating theory in the realm of physics challenges conventional wisdom by suggesting that darkness does indeed consist of elusive particles and that light acts as a predator to these mysterious entities. This theory, often referred to as the particle theory of darkness, posits that darkness isn't simply a lack of photons, but a substance made up of particles in constant motion. This idea presents a shift in traditional physics, suggesting that what we perceive as darkness is, in fact, an inherent presence of dark particles. Proponents of this theory argue that darkness should be recognized as a fundamental element, akin to matter or energy. They suggest that these so-called dark particles can interact with other elements, potentially influencing the fabric of space-time itself. By this understanding, darkness could possess properties and behaviors that we have yet to fully comprehend. Looking at light through this lens, one could see it as a force that is in constant pursuit of these dark particles. This theory suggests that photons, the particles of light, actively seek out and interact with dark particles. This interaction is then believed to cause the dispersion of darkness and the illumination of space, giving the impression of light actively hunting down darkness, converting it into the visible spectrum we perceive. The experimental implications of this theory are profound and challenging. If these dark particles do exist, their elusive nature makes them difficult to detect with traditional methods. However, proponents of the theory argue that as particle physics and astrophysics continue to advance, new methodologies and tools may become available that could potentially detect these hypothetical entities. As with any theory that challenges established understanding, the particle theory of darkness and light has attracted its share of skepticism. Critics maintain that the absence of photons sufficiently explains darkness, and that the concept of dark particles lacks empirical evidence. They emphasize the crucial need for rigorous experimental validation before such a paradigm shift can be considered. In conclusion, while the particle theory of darkness and light may be speculative and unconventional, it nonetheless offers a thought-provoking exploration into the nature of darkness. As our understanding of the universe continues to evolve, it will be intriguing to see whether this theory gains empirical support or remains a captivating concept on the periphery of scientific discourse. Only time and continued scientific investigation will tell.